what is in system? Are you response? Are you seeing my screen? I don't know if if I can't tell
Yes.
that you can see my screen.
Yes, we can see your screen.
Okay, all right. So, what an advisory system is it takes a question from a non-expert. Now, we arrange so that what actually happens is that a person can send in a photo by WhatsApp. And this can just be a photo from the field. A farmer can send a photo of his cocoa plant. Maybe he has some diseased pods or some leaves that have holes. Okay. So the system accepts a photo from WhatsApp, and Jiro will show you how that works. And then the system processes this photo, and within a couple of minutes, it returns a recommendation, a short, specific recommendation. Now, we have not really implemented all of these aspects, but we do have this chain where a photo can be submitted on WhatsApp and the recommendation comes back appropriately. So just remind you what our target was. Our target was to, well, we fall a little short of our target. We will present three photos today, and then we'll provide 3 answers. So I'm going to send this over to Ajiro now. She is going to demonstrate the system. And then after that, Victor will show you some of the inside mechanisms that make the system work. So I'm going to give this to Ajiro right now, and she will continue. So Ajiro, are you there? Yes. Well, I've given. They asked me to give my presentation now. I have to give my presentation now.
Okay, I'm here, okay. Prof. Thank you. Okay. Good morning, everyone. Good afternoon,
yes,
everyone.
Yes, go ahead, please. Yes, go ahead, please.
Good afternoon, everyone. I hope I can be heard.
Yes, please go ahead.
Okay, so I'll try and share my screen so we can see the next phase which Prof is talking about. So on the screen here is our Twilio account that links to the Superbase. And I want to send a picture of a diseased cocoa so I can get a feedback. So this is me getting a cocoa picture from my harvested cocoa diseased plants. So I'll start with this and I will send it across. Sorry, give me a minute. I'll send it across. I should get a feedback of image 1 saved. Can we all see my screen?
Yes.
So we can see that here, I've sent the image and I've gotten a feedback of saved 1 image. So this will go to the database to be processed to get a feedback. So while we are waiting for the feedback that will tell us what kind of disease this is and how to go about treating it in terms of disease prevention and management, we will wait for the response and Mr. Victor will take over from here, who will show us the back end of what is being done before I get my feedback as a farmer to be able to incorporate it into my farm for a better yield. Thank you. So over to you, Victor. I think I'll stop sharing my screen now.
All right, yeah, thank you. I'll just go ahead and share my screen as well. Hopefully I'm able to do that.
Come in, I'm trying to stop
Jiro,
sharing.
you have to stop sharing.
Yeah, I'm trying to stop sharing. And here. Don't share. Have I stopped sharing?
Yes, you have.
Yes.
Okay, thank you.
Can you confirm that you can see my screen now?
Yes, we
Yes,
can.
Victor, I can see
Yes.
your screen.
Okay, yeah. So this is an overview.
Sorry, please, you have to enlarge your screen.
Yeah, I'm doing that. I'm doing that now. Hopefully I can. Yeah. Is it better now?
Yes.
Yes.
All right. So the core foundation of how the model work, I'll just try and give us an overview. We are using CLIP model, CLIP, and it basically is an acronym for constructive language image pre-training. And what it does is basically it matches images with written description. So, and it also matches text description as well. But what eventually happens is that say you have different text underneath, it converts the text into unit vectors, right? So coordinates of unit vector, like a group of unit vector. So if you have similar words, the mathematics beneath is that they are going to have a similar unit vector, sort of similar direction. So that is how it is able to classify similar words or photos, right? So that is the left-hand side. So over here, it's what happened within before the farmer sends the photo. We already have our own database. So we've already captured some information about some common cocoa disease. So what happened is that apart from capturing those information, we also have like prompts. So what we do is that we have 5 to 10 sentences that describe the disease, right? So because we want to give the model enough context, tying just a single sentence might constrain to one meaning, and it might not capture what we need. So in our database, which I will show eventually, is that we have like 5 sentences, like template describing one disease for each of the disease. Then we also have reference photo as well, because sometimes we realize that just having text description might not be too helpful. So we also have reference photos that we have stored in our database as well, that points to, okay, this is an actual CocoaPod or CSSV, whatever this is that we have. So what we do is that when we have this data in our own site, this has already been done. I mean, in the first stage of our development, before the farmer even sends the photo. So the model now comes to play here. The model has two type of encoder. It has a text encoder and an image encoder. So, like I said earlier, it basically just converts the text to unit vectors, and the image as well to unit vector. So what happened is that we also improve it, that we have more than one images as well. The same way we have more than one description, one text description of a disease, we also have more than one image, right? We have multiple images to give the model a good understanding of the disease. Then we do what we call element-wise average. So I mean, we it's possible that the image and the description, depending on how good our description is, they might not be like that's similar, right? So we do like this element-wise average, and we average the unit vectors such that they can align together. So basically just boost the matching algorithm. So now this block here is what this does is it just helps us to calibrate, because it's possible that the two are quite unrelated. For example, if we have a very bad prompt or our reference images are not that clear, we do some granular check to make it more uniform, and we return our final prototype here. So now this is entirely done on our end before the farmer sends the picture. Now, the farmer takes a picture, that's the right-hand side here, and they just send. That's the only thing they have to do. At the point of sending, we use the same model that we use for generating the unit vectors as well, right? But what happens is that it also does the same thing, right? It provides a unit vector for the farmer's photo, and now we have two unit vector, right? Two unit vectors, the one that the farmer sends and the one that our own system has already generated for different kind of disease. Then we do what we call cosine similarities. So this one happens in an external system called Pinecone, which checks how similar our own database vectors compared to the farmer's photo, and we get the most similar image. And yeah, we get the top 3 images that are very similar to what we have in our database, right? And we return the response to the farmer. So this is like an overview, and this is the core concept of how we process and match images. And I'll just quickly go ahead, not to waste our time, and take us
So
through.
wait. Did Ijiro, did something come back?
Yes, Prof.
All right.
Okay.
So show the response. Show the response.
Right. Should I stop sharing?
Yeah, unshare.
Okay.
Because she has some other images she can show.
Oh, that's great. So I'll just wait for the responses before we present the next part.
Yeah.
So I'm sharing my screen now. You can see the last thing we saw was saved one image, but now we have a feedback. Can everyone see my screen?
Yes,
Yes.
we can.
Okay, so now you see we have a feedback that says, hello, it seems your cocoa plants may have a disease called P. megacariosus. Here are 3 practical steps you can take. First, remove any infected leaves and pods to stop the spread. Keep your farm clean by cleaning away debris and fallen fruits. Rotate your crops to improve soil health and reduce disease risk. Please confirm these steps with your local agricultural extension officer for the best results. So before Victor continues, I'll send the next picture. So I'm picking up another diseased cocoa plant, and I'm going to send it to our database to wait for a feedback. Then after Victor is done, we'll review again, then I'll send the last picture.
Okay. So how long did it take to come back?
It took 2 minutes.
2 minutes.
Because it came in at, yes, it came in at 12:10. So it took
at
2 minutes.
12:10. Okay. Oh, it wasn't long at all.
Yes,
well,
it's something we can also wait for.
Yeah. As soon as it, well, let him continue, but as soon as it comes back, let him know, and we can go immediately to the response.
All right.
So just interrupt him when it comes back,
Okay,
just to
sir.
respect time. Yeah. So Victor, she will interrupt you when the response comes.
So have I stopped sharing?
Yeah, please stop sharing.
Oops. What did I do last time? I think I have stopped sharing. I think I've stopped sharing, right?
Yes, you stopped. So
Okay.
Victor, please go ahead and pick up. Oh, he can't unmute. So we need permission from we need permissions to unmute. We need permissions from the organizer. Is the organizer there?
Okay, yeah, I think that's
All right, good. Yes, thank you.
Thank you. So let me take us through our database as well. How we store all of this. Well, I'm guessing I'm going to be interrupted soon because 2 minutes is almost. All right, so
but it may take longer. Yeah, so we'll see.
Okay. All right, so this is we are using Supabase as the platform for hosting our data.
Okay, our feedback is here. Sorry, Victor.
Oh, okay. All right, good. Okay, so it was very quick. Okay.
I suspected that. Let me just.
Okay. All right. So you guys continue. I have to leave now, but you're doing a great job. So please continue.
Okay, so can everyone hear me?
Yes, we can.
So this is our feedback from this diseased cocoa plants that we've sent. And it says, hello, it looks like your cocoa plants may have mealbug disease. You know, the first one was, that's what they call it now, black pod disease. This is generic name for black pod disease. So this other one is mealbug disease. And here are some steps you can take. Encourage natural predators like ladybugs by planting flowers nearby. Consider using the fungus Beauveria bassiana, which is being tested for effectiveness. Keep your farm clean by removing any infected plants to reduce mealbug numbers. Then please confirm the steps with your local agricultural extension. So I'm going to be sending one more disease, and we'll wait for the feedback to see what comes from our database. While Victor continues, what happened? Supposed to share this. Go ahead. Okay, so I'll stop sharing. Victor, you can continue while I do this. Can I be heard? I hope Victor is not muted again. Oh God.
Okay, I guess I shouldn't mute myself. Yeah. All right. Let me just share my screen and continue. Okay. So we have two tables where I was mentioning that we use Superbase. Superbase is an open source backend as a service that we're using. So we don't really want to start to set up infrastructure for things out for something like this. So we have two tables. We have a table that stores the request that is coming from WhatsApp, right? The image, the status. The status can either be pending, matched, ready, or completed. So like these are just metadata that come from WhatsApp, and then we also have a table which is called disease knowledge. So if we check what's inside these tables, so this is the first table where we collect. This is the request. Okay, this is not the first table. This is the request. This is what came in from the WhatsApp. So if I should sort it, we can see that so far they have been completed so far. And yeah, these are the raw treatment advice. At the same time, match score, because our system is is giving a similar information, right? It's not 100% certain. So we also have this similarity score that we return, or that we use to determine whether it is a reliable suggestion or not. So that's basically it. And of course, some storage parts on Superbase as well. Now, this is our disease knowledge table that stores information about the different disease. So far we are planning to extend this, and yeah, I mean, we've been having some difficulties with pictures and all that, but so far our system has been trained on this for disease. And as I was mentioning earlier, we also have this table also contains a list of symptoms, prevention and control. And at the same time, it also has what I mentioned earlier about multiple sentences as well. So if we look at this now, this is for Blackboard. Instead of just describing what Blackboard is with is a sentence or a visual description, we have more than one. We have one, two, we have like 5 description. This can always improve to whatever number, and we can guarantee that we are having a better suggestion as we improve our database around the different kind of disease. So that's basically it's yeah, we also have this storage. Hold on. Wow, trying to move this thing. Anyway, so yeah, that's it. We also have a place where we store our reference images as well, because we want to make reference to them. So we have these images that we use as reference images for our model: Blackboard, CSSV, Millibug, and yeah. So I think this is our storage layer, and the code that actually does the clip utilization is on Colab. I think I would wait for Professor Tron to go over that, because he was supposed to go over that. But yeah, I think that's all from my end for now.
Okay, thank you so much, Mr. Victor and Mrs. Ejuru. I don't think Professor Tron is still on this call with us. I think he left the call. But then we might have questions concerning the demonstration so far. So I would like to ask the participants, please, if you have any question, comments, suggestions, clarification on what has been presented so far by the koko team, please signify by raising up your hand while I ask you to unmute. Adebola, please, you've been asked to unmute.
Okay, so good morning, everyone. Okay, so thank you for the great job you guys have put in there and the wonderful presentation. I was just thinking aloud. Sorry, I just bumped in not quite long, and I saw part of the feedback after you have during the first demonstration and the second one, where we saw the matching of the images, and then we saw a feedback. And I was looking at that feedback. What actually came to my mind was this is supposed to be used by a local farmer. And I'm just thinking around how they will be able to understand that message. Is this something that, knowing fully well that most farmers, cocoa farmers in Nigeria, a lot of them might not be that educated. I'm just thinking of something they call decolonization of information that's come from the LLM. So how are we going to do it such that an average farmer, irrespective of their level of education, can actually understand the message and be able to interpret it so that it can be useful for them? Because I'm seeing a lot of big names there, some botanical stuff. That was just my thinking. Maybe something that we need to consider. That will be my comments. Thank you.
Thank you so much for the comment. I'm sure the koko team have noted that.
Sister Goodness, Happiness, sorry. I just wanted to say something with respect to what he said.
Yes, please go ahead.
Because we're just starting, we're using English, but the feedbacks can be translated into their various local dialects where they can understand what we're trying to communicate back. So their own role is just to get the picture and send it through their local phone anyway. And the feedback will come in both in English and in a dialect that particular farmer can reckon with, understand, and use for his end. What will I call it? Use at his own end. Thank you. But thank you very much for that. We're also putting it into our work. It's a work in progress.
Okay.
All right, thank you so much.
So
Uchemadu, you've been asked to unmute.
Yeah. Can you hear me, please?
Please go ahead.
Okay, thank you very much for the presenters. That's a wonderful work. I just want to ask what Ejiro said, because the observation that the previous speaker made is a very valid one. So the app, the progress, and also before deployment, the farmers should be trained on how to use it. So their main aim is not to interpret the botanical names or start rhyming them. The aim is for them to identify what they can do to save their cocoa in the rural area. And because we have Cocoa Farmers Association, they are organized as well. And not all of them are illiterate. So even if a farmer could not understand, in fact, any person that can upload image, that can use WhatsApp, should be able to understand the response. It's just like texting message to your friends. So anybody that can use WhatsApp should be able to use that app. So in a case where a farmer could not understand it, he can go to another person because they have associations. He can go to another person who can assist him in interpreting the feedback and also tell him how to implement it. So they will be trained. And that's what we call the implementation phase of any program. Most of the things fail, especially in Nigeria, most of our programs fail at the implementation point. So to implement it, they will be trained. In fact, some people that develop the app may need to stay with the Cocoa Farmers Association for some days, use the app, teach them. So in that case, before you know it, everybody will start using it and it will be useful for every farmers.
Okay, thank you so much. Over to Ms. Sejuro.
Sorry, I wanted to add a
Okay.
point to
Okay.
what was an explanation earlier. So the entire response that we've been giving so far, right? They are coming from our database, right? So we can easily improve. Because if you look at this description, yeah, if you look at the table, we have this prevention and control, and this was basically picked from some papers. So we can easily, if we just update this here, we refine the language, and we also have another layer that does the summarization as well using AI. So the reason why the botanical name appeared was because that was the name we used here. So by just updating the database and trying to refine the language, we can get some instant improvements, right? And yeah, of course, we can even decide to attach multiple things in the response as well, like videos and all that. But yeah, that's what I wanted to add, that everything is external to the actual model itself. It's coming from our database, and we have total control of what we decide to show the farmer, and we can tweak it without touching the model in any way. Our core model, the clip. So yeah, just wanted to add that.
Oh, please, can you hear me? Hello?
Yeah, okay. I just started hearing you
Yes, we
now.
can hear you.
Mr. Victor, are you done responding to his comment?
Yes, I am. I think I don't know if it's my network or yours, but I stopped hearing you for a while.
Thank you. So we'll take the last section, the last question for this section. I can see another hand raised, and this will be the last question for this section before we move on to the last section for today and for this fourth school of International School of Modeling and Data Analytics. Mr. Oluwafemi, please unmute.
Hello, can you hear me?
Yeah.
Yes, we can hear you.
Okay, thank you. That is a very wonderful demonstration. I just want to ask if this can be used or can be applied to any other disease apart from this cocoa disease. Yeah.
Okay. That's
Yeah. Okay,
yeah.
Victor, go ahead.
Just go ahead. Do you want to add just
Okay. Very well, because Ask Coco is just an app that is addressing cocoa disease, but it's something that can be replicated in other fields. In fact, after this, I was going to reach out to Victor to tell him that we should work on dermatology. It's an aspect of medicine that has to do with skin diseases. So we can replicate what has just happened in Axe Coco. We'll do it on Axe Derma, and we would have solutions to the public. Why I'm even saying dermatology is because we barely have enough dermatology doc physicians or experts. They're very, very scarce. I think even in Ekiti, if I'm not mistaken, we may have just like one. So if we can replicate this in that aspect, a lot of skin diseases can also be addressed. So it's an app that can be replicated across many fields. Thank you.
yeah, thanks. yeah, just a final addition to that, as you know, the beauty of using this approach is that we don't really need to train the model on, or if we don't even have to train in the first place, because having to train will require a lot of data. Then we'll have to do some classification, and I mean, it's an exhaustive amount of data. But with what we are doing here, it's something that is quite abstract to the area. We just need to know how to describe the disease, right, or wherever it is, and we also have some reference images. And the more we improve our data, right, the more we get response. So we can easily translate this to any field, and as long as you have some reference images, we don't need to have a lot of images, and we also need to make sure that we progressively improve the prompts, right? And I think, yeah, the only thing that is stopping us is just a bit of relevance on what we're trying to achieve in that area, and some data.
Thank you so much, Mr. Victor, Dr. Ejiro, and Professor Chon for the demonstration. My question has also been answered, and would really love to see how this would be implemented in some other field, especially in dermatology, as mentioned by Dr. Ejiro. Now we move on to the last section for today that will be anchored by Professor Bakari Emmanuel. And this section would be on life lessons or life courses. And now I would love to call on Professor Bakare to take this section. Please join me as I welcome Prof.
Prof, you're welcome. Victor, I can stop sharing.